Hello, friends. Welcome to this edition of Space Time and what is happening in space time. This is a daily live show, and if you have any suggestions, you can interact with us. So, today is September 15th. What has happened today? Let's find out. So, friends, first information is about panic being created among the scientific community, especially from the findings of the James Webb Space Telescope, which in short is also known as JWST. And why there is a panic? Because I think there is there is nothing special that they have found, but there are pictures being taken by by JWST in the infrared spectrum, and the idea was to look beyond where the limit of the Hubble telescope has reached. So look beyond in infrared spectrum and see what is behind the capabilities of the Hubble telescope. I mean the limit of the Hubble telescope. What is behind that? What are the events happening in space way back in time? And as per the new pictures, there are a couple of things that are being shown in the pictures. One is which is creating a lot of panic, and I thought I will talk very briefly about that. Is about the presence of galaxies merely 100 million years after the Big Bang, so-called Big Bang. So the reason being that the galaxies like Milky Way and other galaxies, larger galaxies, they need a lot of time to form, because one of the method of large galaxies to form is by the way of mergers. And as you know, friends, that the galaxies are all the time colliding with each other, and by way of these collisions, their size keep increasing. And we have fairly good idea about the processes which are present in the space, and because of which these galaxies, large galaxies, are formed. So the assumption was, if the Big Bang happened about 13.7 or 13.8 billion years back, then the first galaxies would have formed after a billion years or so. And that is what the mathematical calculation is, and that is also the observation that we have received from the Hubble. However, when JWST became active and started taking pictures, JWST in the infrared spectrum was able to detect the galaxies far back in time, beyond the viewing limit of the Hubble. That means there are galaxies that existed even after the Big Bang. If the Big Bang at all happened, then to form a large galaxy, it took only 100 million years. And that does not gel very well with the scientific principles or the observation that we have so far, or the understanding of the large galaxies. That is one of the things that the JWST has told us. Second is that there are many galaxies. It's not only few galaxies. So if there are few galaxies, we can say that, okay, fine, there was a chance that one or two galaxies might have formed very early in the universe. But there are many galaxies JWST has found. And how these galaxies reached there? I mean, how there were so many smooth galaxies, large galaxies, spirals in shape, that existed merely 100 million years after the Big Bang. It is a mystery. So it has pressed the panic button among the scientific community, simply because if there are so many galaxies, then our understanding of how the universe started itself is flawed. So more research is required. And when I say panic, it's not literally the panic. It's basically understanding the nature of the universe. And the Big Bang concept basically came from the Catholic Church biblical belief that there was darkness and then there was light, and eventually the Big Bang term was also given by a priest who happened to be astronomer. So the common belief is that the universe started from a point which was smaller than the atom, and then it banged, and before the Big Bang, there was nothing. So that idea may be wrong after this picture which has been taken by JWST. That means there was no Big Bang maybe, but I'm not saying anything. I'm waiting for more analysis, more evidence to be presented to us. So far, JWST has been in operation for just few days, couple of months, and it is already shaking up things. So let's move to the next one in the space-time. And next one is about dark energy. How do we hunt for dark energy? And as you know that the dark energy is something which is a prime energy that is present in the universe. And why I call it prime? Because if you look at the entire makeup of the universe, 70% consists of dark energy. That means the most abundant item in our universe is dark energy. So dark energy must be playing some role in the formation of galaxies, stars, etc. So we do not know what dark energy is. We do not know how does it work, and that is why we are searching for it. And as the subject says, that it is the hunt of dark energy, and therefore there is a very special satellite which has been working for last couple of years, and this satellite is called DE-CAM telescope. Now, DE-CAM telescope stands for Dark Energy Camera Telescope. So, what DE-CAM is doing, and as you know, friends, that we cannot see dark energy, we cannot observe dark energy, we do not know how the dark energy is produced, what produces it. We simply know that the dark energy is the energy which exists even in the vacuum, complete vacuum. That means that if there is nothing, there will be dark energy in that place. So the DE-CAM is a very special telescope which is out there and measuring the the formation of the matter, the effect of the matter, and it is very specific because it is watching everything in the in a particular spectrum, particular frequency, and the assumption is that because of the effect of some unknown force, this matter will start behaving in a different manner using the scientific algorithms. So it has been observing the Lobster Nebula, which is the leftover of a ancient Big Bang, and it is still expanding. As we know that it's not Big Bang, it's the supernova explosion of a star. So when the supernova explosion happens, then it does not stop. The explosion does not, it keeps expanding. So from our standpoint, it is expanding, and there could be an impact of dark energy on the expansion of the Lobster Nebula. That is being studied by DE-CAM. So it has been able to find out that there is some external effect on the expansion process itself. So this is something which is going on, and so far we have not got any direct evidence of dark energy. It's all indirect, but DE-CAM is working on it and observing Lobster Nebula expansion for last 5 years. And once this whole exercise is over, the a lot of megabytes of data will be generated by DE-CAM, and then scientists will be able to review the expansion pattern, and probably at that time they will be able to come out with some evidence of dark energy. So let's move to the next one, and this is about our favorite subject, which is aliens. The search for aliens is on. There are so many different descriptions, even in the ancient text, that there were visitations from outer space which were non-human. So there were references of intelligent alien life, interaction between aliens, intelligent aliens and humans. But so far we have not even been able to find even a bacteria which is outside of the Earth system. So Earth is bubbling with life. Every ounce of Earth has some sort of life. And when we go to Mars and other planets, even in the neighborhood, we are not able to locate any sort of life so far. So how we basically live with this idea that there are aliens. There may be aliens, and there may be aliens looking at us, or maybe wanting to communicate with us, or maybe wanting to attack us, invasion, etc. How do we assume all these things? So the first thing is that maybe it's not a good idea to venture out, but come back home and then look for artifacts which may be spread across the solar system. Because if we are able to find the evidence of alien or leftovers of the alien who had visited us, then it will be a good starting point to ascertain that there could be aliens in the universe. And especially if you look at the solar system is not a small place. The Neptune, which is the furthermost known planet, is at 30 astronomical units away from Sun, which is 30 times, it is traveling 30 times further out as compared to Earth from the Sun. So, and after that, there is Oort cloud, which is nearly 100,000 astronomical unit. That means it is 100,000 times further out as compared to Earth. So it's not a small place, and it's a very, very big area, big volume to search for things. So I think the best way to look at is basically examine the solar system, and there could be remnants of some technology, some sort of radio signals, some sort of devices left behind by aliens who had visited us in the past probably, or even if they are here. I think the easiest method is to detect the alien artifacts spread across the solar system rather than looking outside outside far off places. Because if we are first of all, the solar system is not a small place. It is large enough to basically search for these small things. And if we don't do that, we will be spreading our efforts very thin if we look beyond the solar system. So I think the first starting point to look for alien evidence will be to look into our solar system and see if there were leftover technology or leftover some sort of a evidence which we can retrieve, understand. And it is not only the physical evidence, it could be evidence in the form of radio signals. Why I'm saying radio signals? Because there are radio waves generated by natural things like supernova explosions or stars, etc. But then the artificial radio signals are totally different from the natural radio waves. We know that. We know the difference between the natural causes of the radio waves and the artificial radio signals. So we can also look for the radio signals which may be emanating from within the objects floating around in our solar system itself. So that is why I think it may be important to take a step back and don't look for aliens outside the solar system. Let's look at the aliens which may have visited us and left certain evidence behind. Okay, so let's move to the next one. Well, Hubble has given us so much. It is a very old telescope, and it has given us crystal clear pictures of very far off objects. And with the launch of JWST, we felt that Hubble may be outdated, but not so early. Hubble is still working, and it is still showing us a lot of stuff. Now, this is the latest picture from Hubble telescope of a small Magellanic cloud. And what Hubble has been able to show us is that if you can see this picture carefully, there are the stars which are rotating in a very spiral form. That means there could be a very high density object in the middle of the spiral which could be pulling all these stars to in that spiral form. So these are very young stars and very bright stars. That means there are new stars being formed in this region, and they are moving in a very spiral orbits around a very heavy object. Now this heavy object could be a black hole, could be a neutron star, we don't know. And Magellanic cloud, even the name is Magellanic cloud, it is a galaxy, a dwarf galaxy which is rotating around our Milky Way. So there are two galaxies, where one is called Large Magellanic Cloud and other is called the Small Magellanic Cloud. Both are on the collision course with the Milky Way. And I think these are something that we can see and examine in a much better view as compared to Milky Way, because to examine something in which we are floating ourselves is difficult. But if you look at the galaxies which are nearby and very, very close, then this is something that we can see. And these Magellanic Cloud is a good observation point for us to understand how the star nurseries are formed. And this is the latest picture from Hubble, which shows that the new stars which are being born are rotating around a very heavy object in a spiral format. So I think more studies required to understand the nature of how the stars are formed. I'm sure scientists are working on it. Let's move to the next one. Well, this is about Jupiter. You know, as we know that in our solar system, Jupiter is the largest planet, and in the past, it had created a situation where a lot of these asteroids and comets were thrown at the Earth. I mean, the inner planets, and this event is called the early, asteroid bombardment. And scientists believe that when the Earth was very young, this happened, and most of the water that is found on Earth was brought in because of this processes. So a sort of imbalance was created because the Jupiter was moving around much closer than it is today. And then when the Saturn formed, the Jupiter started behaving more appropriately, and Saturn being a larger planet, not as large as Jupiter, but it's stabilized Jupiter, and in a nearly circular orbit. As you know that Jupiter now acts as a protector for Earth. It basically gobbles up all the extra material which is lying around in the form of asteroids and comet and pull it towards itself, because if Jupiter is not there, then all of these free rogue bodies will fall on Earth or somewhere in the middle of the solar system, and it create impact for our livelihood. So now it is being working as a protector for Earth. However, scientists have found that this is a major influence, but it could have been even better. Jupiter would have been able to create an even more habitable situation on Earth if it had slightly more elliptical orbit. Right now it is a nearly circular orbit, but if it had more elliptical orbit, then all the other things in the solar system would also be more elliptical. So when you have more elliptical orbit, then Earth will have a more elliptical orbit, and because of this ellipse in which the Earth will move around, there could be a chance that Earth could move closer to the Sun, melting the ice. That means today a lot of ice is frozen, but if it was able to go close to the Sun, then there will be more water, and if there is more water, there will be more chemical reaction or light-based chemical reaction, and because of that, the life would have evolved. Much more complex life would have evolved. That means in a short time, a lot of experiments, permutation, combination would have taken place, and Earth would have become more habitable. And the downside of this theory is that if the Jupiter was in a much more eccentric orbit, then Earth would have been also in a much more eccentric orbit, and because of that Earth could have been going very, very close to the Sun, and that would actually destroy the life itself. So what I'm saying is that if Jupiter was slightly more elliptical, rotating around Sun in a slightly more elliptical orbit, that would have created more habitability for the inner planets and more so about Earth. Maybe Mars would have got a chance to grow life. Then if the Jupiter was slightly more elliptical, then maybe we would have two planets harboring complex life, not only just one right now as we know it. So friends, these are the latest happening in space-time, and I thought I will talk about these things today with you. So if you like and if you have any comments, do send in your comments, and thanks for watching, and I will meet you tomorrow again in the space-time. Until then, please take care, bye bye, and See you tomorrow.